All right, here's example 5, and I know I've changed this on your notes, but it wasn't changed here when I started recording. So this is supposed to be n cubed. Okay, let's prove by induction. And notice I'm giving you this cubic multiplied out. I'm never going to ask you to multiply out a cube. I'll always give it to you so if it's necessary to do. So let's dig in. Okay, so what do I do first? I show true for n equals 0. So plugging in n equals 0 here, I get 3, and I want to show it's divisible by 3. Check. 3 is divisible by 3. Whoops. So now I'm going to assume true. Assume true for n equal k. So if I plug in n equal k, on the left-hand side, I'll get k cubed minus 7k plus 3 is divisible by 3. So what I'm going to do is I'm going to say that k cubed, there we go, k cubed minus 7k plus 3 is equal to 3t, and t is an element of the integers, right? And I want to be able to use this in the next steps, right? Okay, so now I'm going to show true for n equal k plus 1. Okay, so on the left-hand side, I'll get k plus 1 cubed minus 7 times k plus 1 plus 3. I'm sorry, yeah, plus 3. And I want to say that that's equal to 3t, right? So I want to, in some way, find out that this is going to be 3 times a number. All right, so I told you what this is, so you get to plug it in. So k cubed plus 3k squared plus 3k plus 1. Okay, so let's multiply the rest of this out. So negative 7k minus 7 plus 3. And so what I want to show is I want to get to a point that it's equal to, well, 3, I'm going to say is equal to, not 3t. I want to make it a different letter because I want to be able to substitute in 3t. So I'm going to say is equal to 3l. It's equal because this is not going to be the same letter, right? So L, an element of the integers. Right, here we go. So let's see what I've got. So let's join like terms together. So 3k squared. So the k's, between these two, I have a minus 4k. And here I have a plus 1, a minus 7, and a plus 3. So that gives me a minus 4. No, wait. That's a plus 4. So minus 3. And I want to show that it's equal to 3l. Okay, so now this is where you need to remember that you have to use this inductive step, right? You have to use this assume step. So I need to find this in here. Now, all right, so let's see. What if let me just put it in blue here, a little easier to read. K cubed minus 7k plus 3. Okay, so if I gathered, not factored, but gathered those terms, what would I have left? So I'd have the k cubed taken care of. So, and that 3k squared is not in here, so I'd have to bring this along, 3k squared. Okay, so it was a minus a 4k. I wanted a minus a 7k. And so in order to get a minus a 4k left over, I'd have to have a plus 3k, correct? Because this plus this would give me this. So I'm not factoring, I'm just rearranging terms, right? So here I pulled out a positive 3. I'm supposed to end up with a negative 3, so that must mean I must have a negative 6. So just overall, these 6 terms make those 4 terms. K cubed, negative 7k plus a 3k gives me a negative 4k. Here's my 3k squared. And then to get to a negative 3, I have positive 3 and negative 6. Okay, now I get to use my inductive step, right? It always has to be that I'm going to use my inductive step. This gets replaced with 3t. And then, let me just kind of go back to, and then I have this. So remind yourself what you're doing. What I want to get to is that this can be written as 3 times L. Look at this. So 3t plus if I factor I can, which is amazing, I can factor a 3 out of here. So I get 3 times t plus, whoops, k minus 2 equal 3L check. That was kind of creative, wasn't it? All right, so I'm going to leave you to do this one on Zoom.